Good afternoon, ladies and gentlemen. Welcome to our short presentation prepared by Pfeifer Structures and entitled Innovative Engineering Inspired by Art of Visionary Design. This presentation will attempt to demonstrate to you the creative process which was led by architects, Hopkins architects in London, engineered by Webb Yates' office, also in London, and executed on site by Pfeifer Structures. The project is Thematic District Public Shading for EXPO 2020 in Dubai, which is taking place right now. However, before I show you some interesting details about this project, let me take you back in time and remind you of some iconic structures which have been built for previous expos. This one on this slide is a Crystal Palace, which was built for Great Exhibition London in 1851, designed by Joseph Paxton. Another one is the Eiffel Tower on the left-hand side, built for the World Fair in Paris in 1889, engineered and built by Mr. Eiffel. On the right-hand side, you see the geodesic dome, engineered by Buckminster Fuller and built for 1967 Expo, which took place in Montreal, and this structure is also still standing in one of the attractions of the city. Now let's go back to our project. This is the original concept design developed by Hopkins. It is basically a cable net with the number of intersecting cables with occasional inverted cones taking this net down to the ground in form of the trees. And as you see here, everything structurally works in tension with the reaction loads, which have been defined at this point only at the anchors. So when the design developed further, it has been modified a little bit in terms of the size and shape and the connections between individual trees, as you can see here. And then when the engineers were involved, they started to look for the structural definition of each individual tree and to produce a little more clear structural system for each one of these trees. So the steel masts were introduced and the steel compression ring, which resolved the tension forces introduced by pre-tension cables. And then, of course, Yates had to consider all the apply loads and the deformation of the structure and mostly the wind loads. Because some of these trees were connected either in a pair or in a cluster of 4 trees, like is shown on the right-hand side, the webbing between the individual trees had to be considered by the engineers in the analysis. And then when the final site plan was approved, it turned out that these clusters of the trees were actually a little bigger and more complicated. And at this point, Pfeifer Structures got involved in the engineering process, and we have produced our own models, our own analysis, considering the actual final geometry of the clusters, which did have influence on the design decisions of individual trees in terms of the sizes of the cables, the pre-tension forces, the flow forces, and so on. And of course, the final details had to be worked out. What you see here on the left-hand side was just a very generic model of the connections of the intersecting cables, but in reality, the nodes, as you see here on the right-hand side, had to be carefully engineered to consider the transfer forces and the other detailing requirements. For example, the electrical services for all the fixtures which had been attached to the cable net. Then there was additional feature of this structure of the trees, which were the movable aluminum panels, which were attached on two hinges to each of the cables. These had to be developed specifically for this project, including the perforation, including the special hinges on which they operate, and the testing of the prototypes in the labs, and the full-scale mock-ups, which you see here on the right-hand side. Then, of course, the construction had to be considered, the installation. What you see here is the very general concept of the sequence of installation, which had to depend on the construction company who actually could demonstrate the previous experience and expertise. Here you see the example of a cooling tower, a massive cooling tower that was built by Pfeifer in the 70s. So from the design sketches, which you see on the left-hand side, the actual details, the workable details, had to be developed by Pfeifer, which you see on the right-hand side. And then this is the progress of the construction and attachment, installation of individual panels on a tree which is already built. What you see here is the summary of the efforts by a construction company which contributed to the overall design process and the success of the project. You can read it through all of these events, starting through the verification of a 3D model, the deflection analysis, final geometry, the construction of the mock-ups, and the entire erection plan. Let me show you some of the conclusions which may support my statement that the specialty contractor or builder plays a vital role in the overall creative design process, which leads to a successful completion of a project. Of course, the design starts with the architects, but where does it end? In my opinion, it ends on the final building, on the final structure, which is achieved through the collaboration, coordination, and the teamwork. Of course, all the tools, 3D modeling and BIM models, it help in this process, but in the end, we arrive to the final product, which you can see. Thank you for your attention.